Good morning and welcome everybody on behalf of the Minnesota Ag Water Resources Coalition. Welcome to our Wetlands and Drainage workshop. My name is Brad Carlson. I work for University of Minnesota Extension out of our regional office in Mankato. I'm going to be the moderator today. I work in areas related to water quality, row crop production with a specific emphasis on agricultural drainage. And I think most of you guys are more than well aware that beyond the nuts and bolts design work with ag drainage, a lot of our bigger challenges that we have on the horizon are environmentally oriented. And so that's a lot of what my focus has been and is going to be coming into the next few years. This topic this morning actually touches on a large number of different subject areas. I may not have thought of it that way. One of the handouts that you could have grabbed on your way in is this fact sheet that I wrote titled 10 Points to Consider When Planning an Agricultural Drainage System. Obviously, point number one is wetlands compliance, which is going to be part of our program today, and I think we all recognize that some of the old issues from 30 and 40 years ago where when we talked wetlands and drainage, we were maybe discussing draining a wetland and farming it, versus these days where instead we're looking at what is a wetland and what do we need to do to not drain it or to stay away from it so we don't get ourselves afoul of the law. That's pretty obvious, but beyond that, there's actually a number of things on here. This fact sheet was actually, I ended up writing this thing after I did a presentation for a summer field day last summer, where I kind of decanted a lot of the common themes that I got over the previous winter when I did a large number of speaking engagements. These were the things that you guys, the audience participants, kept coming up to me and discussing or saying, this is a problem, what about this, how do I deal with this? Probably the single biggest challenge that I hear from farmers related to drainage these days is an outlet. Do I have an outlet? Or does my outlet have the capacity to take the water away? And I think we all, particularly this year, as wet as it is, we all know all those spots. You see the standpipe out in the field, and then you got the big dead spot out there anyway. So we keep hearing about that. And not only that, another one of these points is impacts on neighbors. I probably don't need to say this, but because you know this, but I will because this is part of the opening comments. Guys coming and complaining, the neighbor did this, the neighbor did this. And particularly, what I hear is, well, I tiled that back in 1975 and everything was fine until the neighbor tiled his and hooked onto the main, and now my land that's well drained floods anyway. And so when it comes to this issue of potentially restoring a wetland, obviously it solves a number of those problems. It gives you a place for the water to go, and potentially, depending on who pays for it and how it's paid and so forth, maybe it takes care of some of those financial situations where a guy's experiencing loss right now and he's not getting anything out of the property. And so through the course of the day, we're going to have a number of speakers discussing this. This has been a developing issue here in the state in terms of how we are going to end up cost sharing this, how we are going to end up implementing this, and how we are going to end up planning for wetlands and drainage. And I think particularly as we move forward in the next couple of years, you've all seen the headlines in the last couple of weeks, whether it was the Star Tribune or the Mankato Free Press or whatever, regarding nitrates in our surface waters. We are at the point now where we have a executive summary, a full report, and an executive summary that lays out what the issue is with nitrates in our surface waters. We've had a national plan or report for a number of years that's looking at reducing nitrate contributions into the Gulf of Mexico to reduce hypoxia. The next step here in Minnesota is going to be actually developing a plan which is on the drawing board. It's not just something that we're talking about or saying it needs to happen. It's coming, in terms of how we're going to actually achieve that reduction, which they're looking at long-term at a 45% reduction in nitrate contributions to surface waters. Wetland restoration is potentially going to be part of that. running the water, detaining it in a wetland is potentially going to be one of the solutions that we have for reducing nitrates when that water eventually reaches surface waters that flow out of the state. And so this issue is only going to become more important and bigger. And so with that, I think we're ready to kind of send you off into the day, because the speakers actually have the nuts and bolts information that you're here to listen to and to absorb. Our first speaker this morning is Kean. Al works for the Board of Water and Soil Resources in Minnesota, as most of you are familiar with, the state agency entity that administers a wide range of state programs related to water and soil, and then interacts with a lot of local units of government, soil water conservation districts, counties, and watershed districts, and so forth, which actually end up implementing those programs. Al has been a point person dealing with issues related to agricultural drainage for a number of years. And with that, I'm going to turn it over to Al.
Good morning, folks. I appreciate you being here. And some of you have heard me talk about this before. It's one of my passions, is trying to promote the idea that we manage our drainage from field all the way to the streams for more than one reason, and trying to elucidate an idea about how do we do that and what kind of practices are involved. So I'll try to give you an overview of that. And what are some of the recent developments that are driving some of this? We know that pattern tiling continues to occur at a rapid pace. For a lot of folks in the city, that's a concern. For a lot of you folks on the farm, that's an improvement, an ability to improve productivity and move forward in that regard. Many of you might know Kurt Dieter, attorney who works for many drainage authorities, and in the last year he's said that he's been assisting more drainage improvement projects than ever before. So there are a lot of drainage activities occurring out there, and for a lot of folks that's a concern. For a lot of folks that's progress. Some of you have probably seen this report that Sean Schottler and others from the Science Museum of Minnesota published this summer called 20th Century Ag Drainage Creates More Erosive Rivers. And it's based upon data from the Minnesota River Basin as a start, but then they looked at 21 different watersheds across the state to try to discern the effects of ag drainage on river flows and erosion of rivers. And Brad referred to the nitrogen in Minnesota surface waters report, recent report by MPCA, which pretty clearly points to subsurface drainage as the largest source of nitrates and nitrogen in our surface waters. So something that is a challenge. And the Red River Basin Technical and Scientific Advisory Committee is beginning a study about the effects of surface drainage on flooding. That group, of which I'm a member, did produce a couple of reports in the last 2 years about the effects of subsurface drainage on flooding. So something else that's worthy of review and consideration. And in recent years, both the NRCS, Natural Resources Conservation Service, and Bowser have had drainage water management initiatives, trying to provide more financial and technical assistance for drainage water management, conservation drainage practices. Saturated buffer, it is a relatively new practice, and the first one in Minnesota is on Doug Albin's farm. Doug will be talking about that and other things I expect when he's on at 11:30 today. So this is a map that is the only one within Minnesota where we have data about tiling permits in the Bois-de-Sioux watershed district since 1999. And of course, that raises concern for a lot of folks about, wow, there's been a lot of drainage in recent decade, and it's true. So if you don't know where the Bois-de-Sioux is, that's the watershed district at the upstream end of the Red River Basin in Minnesota. That's the Red River Basin, again, that large area of North Dakota, Minnesota, and Manitoba. And this is the plot of that tile drainage data that, or permits I should say, that becomes a little bit alarming in terms of the rapid increase. And those are miles of tile, so it's all the laterals of all the pattern tile added up, if you will, part of the reason why it's a fairly large number. But again, just shows that tiling in the Red River Basin, which years ago there was little if any tile in the Red River Basin. It was all done by surface drainage. But now tile has come in, and that's why, again, we as the conservation agencies are trying to promote drainage water management. This is a slide that I've used a number of times, and it has different reactions from different folks, of course. But I believe that, in fact, we should consider drainage to not be a bad word, that it's been going on forever, if you will, and certainly within our state. It's very important for roads to keep them drained so that they remain unsaturated and passable. And in agriculture, within the Minnesota River Basin and the Red River Basin, about half of the land without some drainage is very difficult to farm. And then keep in mind that the publicly administered ag drainage systems across Minnesota, Chapter 103E drainage systems, there's more than 21,000 miles. So it's a vast infrastructure of drainage. And it isn't just agriculture that needs drainage. Towns and cities, stormwater management is a very important part of flood control, if you will, within urban areas as well. So again, the way that I try to stress this, that it's not a question of whether we're going to drain. We always have drained and we'll continue to drain. It's a question of how we do it. And what I'm here to promote is doing it for more than just one purpose. Trying to build into it, if you will, multiple purposes. Some of the concerns, again, water quantity, flood control is a significant issue. And again, that can be viewed in different ways. It isn't just urban flood control, it's agricultural land flood control. Brad referred to the concern that, well, when my neighbors upstream added drainage, now I'm flooding, I'm downstream. And certainly that's part of the concern that we have to build into our considerations. And in recent years, we've experienced a number of droughts, and therefore managing our water to conserve what we can for crop production is also important. Water quality, we have lots of impaired waters across the state. About 40% of the waters that have been assessed are in fact impaired. Concentrations of suspended solids is a big part of that, and nutrients as well. You know, they lead to algae growth in lakes and rivers, high chlorophyll, which leads to low dissolved oxygen. Not good for fish, not good for other aquatic life, and that's a concern. Higher peak flows, more runoff volume equals more erosion, more sediment and nutrients being transported. And keep in mind that phosphorus, P, is primarily transported via erosion and sediment. Again, phosphorus tends to bind to soil particles and be moved by sediment. Nitrogen is primarily an issue with subsurface drainage because nitrogen exists in many different forms, and one of those is nitrate, and nitrates are water soluble, so therefore they end up in tile. So what are the primary methods that we can use for what I call multi-purpose drainage management? Well, runoff hydrology management is a key part of that. And we have many different practices, many different ways that we try to manage the water running off whatever land in terms of rate, timing, and volume to help reduce peak flows. This is a hydrograph just showing flow on the vertical axis and time on the horizontal axis, indicating that if you have storage built into something, you can reduce the peak flow and extend the duration a bit. It's one way to manage our waters. Erosion reduction practices, designs, something that we've worked at as conservation minded folks for years and years. So we want to keep topsoil where it remains productive soils. And we use gravitational and biological treatment of runoff, settling basins and water and sediment control basins, buffer strips and other types of vegetative way to trap nutrients and uptake those nutrients. We also use bacteria and microbes as part of treatment processes. We'll talk about that in terms of wood chip bioreactors. This is a slide developed by the International Water Institute as part of the subsurface drainage effects on flooding study. The only way that those of us who are a member of that committee could talk to each other about soil profile water was to separate it out into its components. So within the soil profile, there's hygroscopic water. That's the water that's bound tightly to soil particles. The only way to get rid of it, if you will, is to bake it off. It's bound tightly. Then there's plant available water. That's the water that's in between these soil particles, that it's there because of capillary action, and again, it's not drainable water. But crops, plants can use that water, so it's plant available, but it's not drainable. And then in between all those soil particles, the fissures and porosity in between particles, that's drainable water. And then the depression water on the surface, again, not looking at surface drainage and runoff there, looking at, again, those, call it more the micro storage on the surface. And what we were trying to look at is that, well, what happens whenever we affect one or the other ways that water is managed? So, you know, what's one of the ways that the hydrologic cycle works? Well, evaporation. You know, evaporation from the surface is a key part of how water returns to the atmosphere. But there's also transpiration. And this is an area that there is sometimes controversy about the effects of tile drainage. And certainly where you have tile drainage that results in better crop stand, you actually have more transpiration capacity during that growing season. What's another way that the water recycles? Well, infiltration, deep infiltration. And this is an area that there's a lot of concern today about groundwater. The picture or poster, if you will, child within Minnesota is White Bear Lake, where again they found that, well, one of the key reasons that White Bear Lake has gone down and doesn't rebound is groundwater pumping, but primarily again for domestic water use in the metro area. Deep infiltration is how that groundwater gets recharged. And then if we add tile drainage to the land, part of that water is shunted via tile and has less opportunity to transpire or to evaporate. So that's part of why the Sean Schottler report indicated that, well, with agricultural drainage, in this case tile, but surface drainage as well, we do tend to increase the runoff volume because more of that water has less opportunity to evaporate or to transpire. So those are things to keep in mind as we look at different practices and how to manage water. I like to consider multipurpose drainage as the umbrella term, if you will, how we try to manage drainage for, again, multiple purposes. Here's the purposes that I've outlined. Adequate drainage for ag production. Key purpose, reducing runoff volume and peak flows to reduce flood damages. It's another purpose that we can build into how we manage water. Reducing erosion of agricultural lands to protect productivity, something we've been doing for forever, if you will, trying to have good conservation practices on the land to reduce erosion. And more water quality is a concern, and it's a purpose that we need to try to build into multi-purpose drainage management. And again, we can do that by reducing field ditch and stream erosion, by reducing pollutant concentration, i.e. via nutrient management, for example, and carrying capacity. So those are some of the ways that the conservation practices help manage for water quality. And clearly, if we can improve wildlife habitat, that's a good thing. The other thing that I think we need to think about is improving resiliency. That word, I think, is a good one to use in the fact that we know that our rainfall has been a lot more intense in recent years, and therefore, one of the ways that we can help reduce erosion and improve water quality is to improve the resiliency, the ability of the land to handle those high intensity rainfalls that we've been getting in recent years. Here's the way that I like to think about a hierarchy, if you will, of terminology. It's difficult to even talk about some of the practices because we all use different language. You know, within the NRCS Field Office Technical Guide, there's 111 conservation practices. And those are the field, if you will, of all conservation practices. From that, there are some that are multi-purpose drainage practices in my lingo because they achieve multiple purposes on the land. And then within that, there's the subset of conservation drainage practices, something that we have developed new practices for water quality protection in particular, and water volume management that we call conservation drainage practices. And then there's a subset of that that's drainage water management practices, otherwise known as DWM. And I expect that you'll hear a bit more about that from Anna Bramblett, who will be talking on behalf of NRCS today. Here's another way to think about those practices. We have on-field practices, how we farm, how we cultivate, etc. We have on-farm practices, and one of those might be wetland restoration. But it might not be on everybody's farm. It might be on some land that's suitable for that, not all. On drainage system practices. This is part of what we're trying to promote in terms of drainage authorities and private landowners. What can you do on your system, which again might be a wetland restoration, or it might be some kind of a pond, if you will, that helps manage the drainage water on the system. And of course, you can think about it as structural and non-structural practices as well. So here's a list of what I call old and new drainage management practices. Again, some of these, they've been around a long time. Residue management, cover crop, relatively new one, if you will, but not completely true, because we've used cover crops in agricultural production for a long time, but there's a resurgence of trying to look at why that really is a beneficial practice for water quality, erosion control, etc. Nutrient management, and this is Conservation Activity Plan is a nutrient management plan. Again, not something that's brand new, and in my opinion, this is one that we do call a conservation drainage practice. We call it a drainage water management practice because it's focused substantially on water quality. Grass waterways, of course, been around forever, but they aren't quite as popular as they used to be because they're in the way for large equipment and for Roundup ready crops. So there's been more emphasis on water and sediment control basins in recent years because they fit better into agricultural production. And many people don't think about terraces as being something that is a water management practice, but it is, because it's one way to detain and meter flow and prevent concentration of flow that causes erosion. And we have in more recent years, again, drainage water management practice. So again, really primarily about controlled subsurface drainage in our neck of the woods. And that involves structures for water control. Again, a new conservation drainage practice, denitrifying bioreactor. I'll show you an example and we'll talk a bit about that as well. Surface drain, replacing open inlets with dense pattern tile or gravel inlets, another way that we're trying to avoid direct movement of soil into a tile system. Wetland restorations, constructed wetlands, and actually within that constructed wetland there's a CRP practice that has existed for several years, and we're trying to look at, well, how can that be improved? And Brad referred to it as a treatment wetland. And so that's something that there's more emphasis on trying to figure out how can we provide good incentive and good technical assistance for treatment wetlands into the future. And another new one, vegetated subsurface drain outlet, otherwise known as a saturated buffer. And Doug Alban has the first one in Minnesota on his property. We'll hear about some more, I believe, and I'll talk about that a bit more as well. So here's some of my guiding principles for trying to use multi-purpose drainage management. What are we trying to do? Well, we're trying to avoid runoff concentration as well as wind erosion too on our fields. Protect concentrated flow areas from erosion, reduce peak flows to reduce erosion and flooding and to improve water quality, reducing runoff volume and nutrient loss by increasing soil water storage and evapotranspiration. We have practices that can help do that. Managing nutrients carefully, that's nutrient management planning and application. And certainly doing all of these can help build our resiliency to those intense rainfalls. And clearly something that the legislature is very concerned about is targeting. They want to make sure that the state dollars are targeted to where they'll produce the best investment, if you will, or the best return on investment. And I'm suggesting using both individual incremental practices, but also watershed approaches. And again, we're all trying to focus more on that watershed approach to how we plan and implement. So, guiding principle number 1, avoiding runoff concentration and wind erosion. Well, how do we do that? What kind of practices? Well, certainly tillage practices are a key part of that. No-till, strip-till, more difficult in Minnesota than they are in southern latitudes, if you will, but we have certainly some farmers who have figured out how to make that work and how to incorporate it into their rotations. Contour strip cropping, certainly down in the southeast part of our state, that's a very big deal because of the topography, and there's a lot of contour strip farming in that part of the state. There also is in other parts of the state where there's significant topography. Cover crops, again, something that I really do believe has significant opportunity, but difficult to incorporate in our rotations to date. Protecting concentrated flow areas. Well, certainly grass waterways have been around a long time, and they work, but they also have their challenges. Typically, the biggest challenge is erosion adjacent to them, because it's difficult to keep your tillage going straight across them. If you run your tillage equipment down along them, well, now I've got grooves in the soil that tend to focus the water, and I can have erosion right next to a grass waterway too. So it requires some careful management. This WASCOBs, that's water and sediment control basins. You can't see this picture real well, but there's a series of 4 or 5 here in this, what otherwise would be a gully. And so these water and sediment control basins, they trap sediment, so it's a gravitational water treatment method. They meter flow, so they're helping to reduce concentration of flow and reduce peak flows. Again, something that I think has been used a lot more in recent years because they don't take up a lot of footprint, and you can farm then parallel to them, and they aren't a big problem, if you will, in terms of a larger equipment. Again, cover crops, something that certainly can provide vegetation during the parts of the year where we don't have growing row crops. So significant benefit in terms of avoiding concentrated flow. Side inlets, this is one that's a small pipe with a riser here. Again, trying to avoid erosion from field water into the ditch. It's a practice that I think has a lot of benefits. Not only do you meter the flow, but you avoid this erosion here, and by metering that flow you also get sediment trapping, water quality improvement. So it's a multi-purpose practice, if you will. Terraces. Maybe not as popular as they used to be, but they still work just as well. And in landscapes where you have a lot of topography, it can be a very, very beneficial practice in terms of keeping the productive soils on the land and also metering water that again helps to achieve the multiple purposes of reducing peak flows, reducing concentration, trapping sediment as well. This is a large water and sediment control basin down in southeast Minnesota where there's significant topography, and clearly again these practices help trap sediment, meter flow, reduce peak flows, reduce erosion, if you will, downstream from them. I tell folks that, down in southeast Minnesota in 2007 we had 500-year rainfall event, and lots of erosion, lots of damage. In Winona County, they did a count of how many water and sediment control basins they have. The number is 1,600. So over many years, there's been a lot of them built down there, and if you took a look in the watersheds below them, they did their job, and not very many of them failed. Most of them survived a very large event that was much bigger than what they were designed for. So again, a good practice where it fits. Culvert sizing, something that the Technical and Scientific Advisory Committee for the Red River Basin had developed a technical paper about this, number 15. It's on the Red River Water Management Board website. But how do we size our culverts to use our road network, which is vast, as a temporary detention system? Not trying to detain water for very long, 24, 30, maybe 36 hours, just helping to reduce peak flows. And clearly, it can help reduce washouts of roads downstream. It can help reduce flooding of agricultural lands downstream as well. But not something that's an easy sell to a road authority. They're concerned primarily about safety, and therefore multi-purpose is a bit of a challenge. But there are some areas where that has worked pretty well. One is down southwest Minnesota. They do projects that they call road retention projects. What are they? Well, they're using the road as a dam. It may already be to some extent, but let's say it has an old bridge crossing that stream in a ravine and a coulee, and the road embankment has poor sight lines, so whenever that road is improved, they need to raise it. Well, at the same time, maybe replace that bridge with a culvert, put a riser on it, and a low flow conduit at the bottom, so that you can have some temporary detention. They're looking for on the order of 24 hours, 36, 48 at the outside. So again, not long duration. Where you have, for example, pasture, works quite well. It's quite compatible, multi-purpose. And up in the Red River Valley, many larger impoundments. For those of you who maybe know something about some of the projects up there, one that's relatively recent is now I'm forgetting the name. Can't remember.
North Ottawa.
Thank you, North Ottawa. North Ottawa project, a large impoundment built on otherwise agricultural land, but it was where at one time it was the swampiest land. And through building this impoundment, they also were able to modify some of the drainage upstream to help put it into that impoundment, and actually improving then the outlet, if you will, for the upstream drainage. So again, something that's multi-purpose, can achieve more than one benefit at one time. Reducing runoff and nutrient loss. Well, again, residue management, clearly those practices can help. We've talked about drainage water management. I'll show you some examples of the types of practices and wetland restorations. Again, one way to increase evapotranspiration, because you have vegetation all year long, and therefore you have evapotranspiration occurring throughout the non-winter season. Soil health, soil quality. This is another area of initiative in recent years, trying to promote the idea that we do need to think about soil health and managing soil biology as a way to manage soil nutrients, something that I think has significant promise. It also, well, I just want to point out here too that, you know, when we plowed the prairie to farm, we have some of the richest soil organic matter soils in the country, if not the world, because of all the prairie vegetation that existed. And if some of you have ever seen the display in the soils building at the University of Minnesota, you know, 10-foot tall grass with 15-foot long root systems, very, very deep root systems, and they kept adding organic matter to that soil. So we're farming that legacy of soil organic matter, but we have depleted a lot of our soil organic matter. And drainage actually is one of the ways that we deplete it, because the more we aerate the soil, the more we actually tend to oxidize organic matter. So how do we put it back becomes a real issue. But here's something else that I think is really important to consider. Our soil scientists at Bowser had run some numbers. So well, if we increased soil organic matter by 1%, how much difference would it make in the top 30 inches, so again in the typical root zone for crops, how much would it increase the water holding capacity of that soil profile? Well, for typical Minnesota soils, it's 3/4 of an inch to an inch. The average runoff in the Red River Basin along the western side of our state is only 4 to 5 inches. So that's a big deal. That's a significant part of the overall water budget, if you will, within much of our lands. And what's that worth in terms of plant available water? Well, about a week to 2 weeks more of plant available water. And remember, plant available water is not drainable. I can't drain it if I try. So therefore, it's bankable water, if you will. And it really can be there for our crops. Cover crops. Again, all the research I've done looking into this, it's a challenge in Minnesota. But one of the things I point out is that, well, with increased pattern tile drainage, we can much more reliably get our crops in on time. This year was quite a challenge because of weather, but certainly pattern tile helped provide more opportunity for getting it in on time. We have shorter growing season hybrids, corn in particular, so therefore we have more window on the backside for cover crops. And there is more and more experience in Minnesota, so I think that there's more opportunity. Managing nutrients, well, how do we do it? Well, we talked about nutrient management. It's planning, trying to figure out what's the best way to manage my nutrients for my crops for maximum productivity, but also to minimize loss of nutrients, in particular nitrogen. Wetlands as treatment. This is one in Nicollet County that was restored via CREP and Reinvest in Minnesota Reserve Program. For a few years in the mid-2000s, it was monitored. The upper plot here in red is the concentration of nitrates coming in. The yellow is nitrates going out. Average of about 80% reduction in nitrates. It clearly works. There's no question that wetlands are good for nitrate reduction. Controlled subsurface drainage. Here's just a plot of soil profile water management during the year, trying to show how these control structures can be used to help manage the soil profile water during the year to help reduce the transport of nitrates in particular. And the way that works is primarily via managing the volume of water. So if I can hold the water back and I can have more of it be used for the crop, for transpiration of that water, then less goes downstream. There's less potential to transport nitrates. Wood chip bioreactor, again using wood chips as a medium for bacteria and microbes that are very good at processing, breaking down nitrates into nitrogen gas, of which is not a problem. And the air is largely composed of nitrogen. So these work. One of the challenges is that you can't build them big enough typically. You can't afford to build them big enough to treat all of the tile water. So typically they're built to treat 20% of the capacity of that tile. And depending upon how the rains come, more or less of that water is actually able to get passed through them. I mentioned that both NRCS and Bowser have had drainage water management initiatives in recent years. NRCS has been doing it since 2012. They use flat rates for the practices that are involved. The Board of Water and Soil Resources, Clean Water Fund Conservation Drainage Management Program, which we started up last year because we were given additional $700,000 specifically for drainage water management types of practices. And I'll show you where those are, the local governments who are participating are located. We use a 75% cost share rate, so 25% non-state is required. We're coordinating our conservation practice standards. Matter of fact, today there's training for drainage water management in the Red River Basin. It'll be coming to southern part of the state in the coming weeks. So we're trying to help folks who provide the technical and financial assistance know better how to do that, both in terms of technically as well as managing those programs. Something that didn't used to be true, but it is in the last year, is that it didn't used to be able to use drainage water management practice money on retrofitting, on new tile, only for retrofitting old tile. But in the last year, that's been changed. Both the federal and the state programs can now cost share on planning and control structures on new pattern tile. Again, you recognize that whenever pattern tile is laid out, it's a key decision point. And oftentimes, if you're designing controlled subsurface drainage, you need to lay it out differently than you otherwise would. You know, lay the tile on the contour. And that may be 90 degrees from the way you otherwise would have laid those laterals. So we need to do it when the new tile is going in the ground, if you will. Here's where the MAWRC program last year, this targeted drainage water management, those are the LGUs that are participating, trying to get areas that had a substantial part of their land that's between 0 and 2% slope, where controlled subsurface drainage works best. Here's the kinds of practices that are eligible. The Conservation Activity Plan 130 is the plan development. It must be prepared by a TechReg technical service provider. In the last year, the list of technical service providers in Minnesota has about doubled or tripled. So we've been promoting the training, trying to have more and more TSPs out there who can provide that service. Structure for water control, that's these types of structures. This is a inline stop log structure. This one's called a water gate. It's a float controlled structure. Doesn't need to be manual operated. If you raise the tailwater on it, it raises the floats, flips the gate, and it'll hold back another foot of water. So it works very well. And it's out of sight, and it doesn't require operation. A good invention, if you will. And then there's cost share for the first 3 years of operation of those plans. And I think Anna will probably tell you more about NRCS's program, the EQIP program. And operation can include fall drawdown for spring storage. Something that's very important to the folks in the Red River Basin. Trying to, again, have that controlled subsurface drainage be operated for multiple purposes. For water quality by holding water back and letting the crops use it, but also for potential storage of water in the spring runoff in the soil profile. So a way to help provide multi-purpose drainage management. Showed a denitrifying bioreactor. The interim practice standard for NRCS is 747. And as I mentioned, wood chips are typically the carbon source that are used as the food, if you will, for microbes and bacteria to do denitrification. The anticipated lifespan of these things is 20 years-ish, but there hasn't been a lot of them around for that long, and therefore it's a little bit uncertain as to whether or not they'll last that long. But I think the experience to date has been pretty positive that they hold up for quite a long time. You do need about 4 or more hours of contact time of that water to be able to do the denitrification process. Therefore, it has to be designed such that it does have that kind of residence time. Has control structures on both the outlet and the inlet. So part of the tile water is being diverted through it. And again, typically, they're designed for 20% of the tile capacity so that the size is reasonable. University of Illinois and Iowa State have developed spreadsheets to help design these things. So there is a way to do that is relatively straightforward and painless. And we're looking at trying to provide some more training for those who are designers for denitrifying bioreactors because they're quite new. Nutrient management, just talked about again, that is an eligible drainage water management practice. It's part of the overall equation of how we manage both the water and the nutrients, particularly to reduce nitrate movement downstream. The state drainage water management program does include replacing open tile inlets. So can replace, let's say, this open tile inlet with a dense pattern tile, or gravel inlets are another way that folks have done that. I'm not a super big fan of gravel inlets in terms of their water quality benefits, but we believe that over time soil does get into the gravel. Essentially it becomes a more pervious area than the soil profile itself and can trap sediment as the water is flowing into that system. Something that Brad referred to that we have to be very cognizant of too is not running afoul of the swamp buster provisions. So you need an AD 1026 form for these tile inlet projects as well. I talked about this one as being a relatively new one. Again, vegetated subsurface drain outlet is the official title of this practice, which is interim practice number 739. It's otherwise known as a saturated buffer. And I'll show you a picture of one so you can get an idea of how that works. First one that we know of for demonstration was along Bear Creek. Iowa State has done a lot of work along Bear Creek, which is not too far from Iowa State. So that's a place where they had done some work. Dr. Dan Janes is from ARS, Iowa State, is heavily involved in those demonstrations. And I mentioned that the first demonstration in Minnesota is at Doug Albin's farm near Granite Falls, and it was installed late last fall. So I don't know if Doug has much data to date on that one, but certainly something we'll be keeping an eye on in terms of how it works. And the Agricultural Drainage Management Coalition has received a Conservation Innovation Grant from NRCS for demonstrations in Iowa, Illinois, and Indiana as well. So this practice is being demonstrated around the Midwest to see how well it can help. So this is Bear Creek, where major buffer strips were put in this section, this reach, years ago. And here's where there are field tile, in these cases running down along the grass waterways. They put a control structure in that tile, put in a distribution line that's parallel to the ditch and the buffer strip. So trying to then push that water out from this tile into these distribution lines and have it soak through the ground to the creek. They installed observation wells down there too to monitor, to see how effective this practice is. Here's a picture just showing the control structure here. So there's a tile that runs this way down to this control structure. This is the parallel distribution tile. Note that it is put back behind the trees because clearly putting it under trees, it gets plugged in time. So it's important to put it where you don't have the deep-rooted vegetation that can cause a problem over time. In this particular case, they used a triple chamber, but normally you'd only use a double one. You'd want to, here's that distribution tile. You'd want to have the stop logs here to be able to raise the head and push that water through those distribution line. In this case, they had added a chamber because this is where they're doing their flow measurements for inflow, and here's flow measurement for outflow to see how much water is going in the distribution line. So in the demonstration, they used a triple chamber. So how does this work? Well, you're inducing seepage flow through the buffer, if you will. Here's that distribution line, and again, it's just using the principle of water moving through the soil, and you therefore provide more water for the vegetation in the buffer, so you get uptake of water and nitrogen in particular, other nutrients as well. So there's also denitrification that's occurring in this vadose zone, and where there's bacteria that are working in the soil too, so they help denitrify. So you're doing it via uptake, you're doing it via the denitrification process. So using, again, a biological treatment approach for drainage water management. Something that in the design of these need to be aware of is that you could potentially increase the surface discharge along the bank of the ditch or the stream, and it may end up causing slumping. So one needs to design these things in a way that tries to avoid that, and also consider what kind of soil profile I have whether or not that might be more or less of a problem at a given site. And again, these last slides were from Dr. Dan Janes at ARS Iowa State. So when do we really have opportunities for looking at multipurpose drainage? Well, whenever you develop a field or a farm conservation plan, look at multipurpose drainage as part of that. What can I do on my fields and on my farm to help manage water runoff? Again, avoid concentration, avoid erosion, and reduce peaks and all of that. Well, what kind of conservation practices can I use that help achieve that? You may have heard about the new Ag Water Quality Certification Program in Minnesota. Again, we're the first state to try to do this. It's certainly going to be an opportunity for conservation planning and for looking at, well, how can I get my farm and my field certified by using multi-purpose conservation practices. So improvements in drainage systems at the field scale and at the drainage system scale. Trying to look at how can I do this in a way that is more multi-purpose than maybe I have in the past. I'd like to also just point out here that, now let me back up. What I wanted to stress on this one too is improvements. You remember I said that Kurt Dieter said that he's helping more improvement projects in Minnesota than he ever has before. It's a major decision point time for drainage systems, be they private or be they public. It's a time to look at, well, if we go this route with these kinds of practices or this kind of design, will it be more multi-purpose? Can we incorporate that at the same time that we're doing an improvement? It's a key decision point. So I'd just like to stress to anyone who's a drainage authority, drainage engineers, that improvements are a key time to think about multi-purpose drainage management and design, because you're making a major commitment of money, major commitment into the future for how that system is going to look and operate. And I'd like just to point out too that, you know, there's more than one way to increase drainage system capacity. I can also increase capacity by increasing upstream storage, i.e. if I can reduce the demand on the system, I've essentially increased its capacity. And how do we do that in terms of, you know, using water and sediment control bases, terraces, wetland restorations, side inlets, which I pointed out too that not only do they solve an erosion problem, they provide an opportunity for very short-term detention along the drainage system, and there's many, many, many side inlets. So there's great opportunity along our drainage systems to use that practice. We talked about controlled subsurface drainage, trying to help save some of that water, particularly in the summer, for the crop use, rather than sending it downstream along with nitrates. It's a practice that does work. And certainly larger impoundments too are a way to help manage storage and therefore manage my peak flows of runoff and actually increase the capacity of the drainage system downstream by managing that water upstream. So what are some of the key challenges to this approach? Well, decision makers believing that in fact this multi-purpose drainage approach is worth it, that it doesn't unreasonably compromise a key objective. And certainly for agricultural drainage, what's the key objective? Well, it's drainage for agricultural production. And within a town, a city, it's drainage for flood control, trying to keep my houses and streets dry. Can I do this multi-purpose drainage thing without overly compensating or overly compromising, rather, my key objectives? I think the answer is yes. There are ways that we can incorporate many different practices for multi-purpose drainage that do not unreasonably compromise my key objectives. But in that regard, for a lot of landowners, the belief is that, well, bigger and more capacity is better. The faster I get rid of that water, the better. The reality is, I don't really have to get rid of it right away. If I have an adequate outlet that I can know that it's going to get off within a certain amount of time, I can achieve the objective of that drainage for agricultural production while still not, putting quite as much water as fast downstream. So here's another challenge that we have. How do we integrate public and private benefits and funding in a way that is considered reasonable for the landowner, reasonable for the public who is helping to pay for something, for other benefits, say it water quality, habitat, all of that. We're always looking for ways to try to integrate public and private money in a way that's comfortable for all of us, that it makes sense, it feels fair, and we can achieve multiple objectives with an integrated design. In recent years, Minnesota drainage law, and actually over quite a few years, there's been provisions added to drainage law to enable multi-purpose projects. They maybe aren't utilized as much as they could or should be, but they are there. So there's an ability for our public drainage systems to incorporate outside money for wetland restoration, water quality, flood control. So it doesn't have to all be paid for by the landowners and the systems. It can be paid for partly by outside money. Drainage water management, our programs, that's part of what that is. It's how we're trying to integrate public money into private systems for water quality protection. I sometimes hear this at the legislature, that the way that we do conservation is random acts of conservation, that our incremental practices here and there don't provide enough benefit. They aren't worth it. Well, the reality is that for those of you who work for a local government unit and NRCS as well, you provide technical and financial assistance. We need to be ready when the landowner is ready. So for me, incremental practice implementation is a key part of what we do. I pointed out earlier that in southeast Minnesota, in just Winona County, 1,600 water and sediment control basins. Those didn't occur all at once. They were incremental. They occurred over many years, but they added up to a significant effect, a significant benefit. But more and more, we are trying to think about planning and implementation at a drainage system and a watershed approach. Very rational way to deal with that. How do we work together within a system to put practices where they fit, and they don't all fit on everybody's land? So how we can integrate watershed-based approach to planning and implementation so that we're taking advantage of topography and landscape opportunities for different practices that maybe, again, don't work everywhere, but overall they can really help the whole system. It does require more planning and analysis, broader expertise, but it often has much more opportunity then to integrate these practices over a larger area. So in my opinion, we need to pursue both the incremental and the watershed approach. And clearly, if we want to keep everybody happy about using money wisely, we need a target. Trying to say, well, where will this money do the best, the most good? So targeting is a good thing. But we're talking about, again, a big endeavor here. This isn't something that can occur in 1 or 2 years. We need to have it just move ahead as a trend, if you will. Some bottom line thoughts. Some amount of drainage is necessary. Again, we've done drainage forever. All the societies before us did too. It's a question of how we do it. And can we do it more multi-purpose? Drainage infrastructure, it's vast across this state, not just our state. All of the Midwest has lots and lots of drainage. That infrastructure, I'd argue, provides opportunity. How we manage those systems throughout all of our lands, both agricultural and urban, makes a difference. It can add up if we are together on how to do it. We have many old conservation practices that I believe are multi-purpose practices. They fit under the umbrella of multi-purpose drainage. And we have many new practices we've developed in the last 10 to 20 years. We're trying to add many more conservation drainage practices, ways that we can achieve multiple goals with practices that make sense on the land. And many of those BMPs, they work best at the headwaters, you know, where there's a smaller drainage area. And clearly, there's a whole lot more headwaters than there are main stems. So we have a lot of opportunity for how we can manage that runoff throughout systems starting at the headwaters, if you will. And therefore, I believe that multipurpose drainage management, it is the right way of thinking. It's worthy of our support. And in order for this approach to be effective long-term, we need to figure out how we can work together, integrate it into our systems, in our operations, in the way that we manage all of our runoff. Brad, I'm going to ask a question. I've got just a few more slides that I could use, but if we are tight on time, I won't. Okay? I wanted to give you just an overview of some of the changes to Minnesota drainage law in recent years. They were recommended by the Drainage Work Group, Stakeholder Drainage Work Group. It's been around since 2006. It's a voluntary coming together of stakeholders from many different perspectives. Agriculture producer groups, we have agencies, we have environmental groups, we have lobbyists, we have all kinds of folks. We have academic folks who are part of this drainage work group. Its focus has been on policy. And a lot of that focus has been on how we can update Minnesota drainage law to be more workable, more multi-purpose focused. So one of the things that we did, and it was recommended back in 2006, adopted by the 2007 legislature, was to clarify the point of beginning for measuring buffer strips. It was unclear. Well, where do you measure that 1 rod buffer strip from? Is it from where the top of the bank of the ditch was when it was first built? Is it where the top of the ditch exists now after it's been improved and or maintained over many years? And in fact, it is. We said, well, it should be at the top of the existing ditch. Wherever that top of ditch is, start measuring from there. We did also clarify that for redetermination of benefits, the way the language was originally written, which has been a requirement actually since 1977, but its roots go back to 1959 when a permissive authority was first given. But the way that it was stated was, well, that 1 rod buffer strip it's a minimum of 1 rod or to the crown of the leveled spoil. So they were trying to take it out to the high point of the spoil bank. If you're doing a redetermination of benefits, there's no work being done on the ditch itself. Therefore, if you use that definition, you'll end up taking a strip that's variable width and not very practical. So in that case, we recommended that, well, we change the language so that for a redetermination of benefits, it's 1 rod, period. So that the Drainage Authority knows how much land that they need to have the system acquire and plant to perennial veg. And it used to be that it was only grass that could be planted in those buffer strips. Well, we have ditches in northern Minnesota, in particular, where there's forest along the ditch. It doesn't make a lot of sense to cut down the forest to plant grass along that ditch. So again, what we try to do is say, let's be practical. Let's say perennial vegetation, and the Drainage Authority gets to determine what kind of perennial vegetation. So again, trying to make sure that we aren't planting something that maybe isn't compatible with the situation. Created an authority for incremental buffer strips and site inlet controls, trying to enable a drainage authority to put them where they belong, if you will, where they would really be effective, and be able to pay for it via repair funds. Don't need to do an improvement to do this. You can use repair funds to put in incremental buffer strips and site inlet controls. And keep in mind too, these site inlet controls, they've actually been cost shareable under EQIP and under state cost share forever. It's a grade stabilization structure. It's one form of grade stabilization structure. So they've been cost shareable for a long time. Require inspection of drainage ditches minimum every 5 years. The previous language was periodically. And there was concern that, well, that's not very definitive. What if periodically is once every 100 years? Those ditches ought to be inspected more frequently. So the language was changed to require a minimum inspection every 5 years. And if there is a violation of that 103E021 is the buffer strip requirement, which is tripped by appointing viewers. So again, not every ditch has a requirement for a buffer strip at this time. If viewers haven't been appointed for an improvement, for a redetermination of benefits, for example, or some repair that required additional land rights, you haven't tripped the trigger yet to require that buffer strip. But where that requirement exists, if there is a violation, then the ditch needs to be inspected annually, until that violation is resolved. And we also clarified drainage system responsibility to restore damaged conservation practices. There was concern that repairs were being done, and if there was a conservation practice along that ditch, say a buffer strip, that it was being damaged, but it wasn't necessarily always being repaired. This just clearly says, yeah, drainage system, you need to repair it if you damage that conservation practice. So again, in 2009, actually, the Drainage Work Group took some more consensus recommendations to the legislature. They didn't get dealt with in 2009 because it was a very difficult budget year. And some of the policy things got pushed aside. It was brought back in 2010 and was approved. One of the things that we recommended was modifying 103E227, impounding, diversion, and adding this rerouting of drainage system waters. It's a piece of drainage law that we use frequently on public drainage systems when we're doing a wetland restoration. So that the drainage system needs to approve that restoration that's part of the system. Sometimes we have to reroute a tile or a ditch around a wetland restoration. And it wasn't clear, well, who owns the ditch if we do that? And so we clarified the language to say, well, clearly, if we're rerouting a public system, the public entity owns that. Actually, again, it's the landowners who own that system. But it becomes part of the system, if you will, and therefore should be maintained just like the rest of the system. We also changed the language to better enable public-private partnerships. So programs and public drainage systems can work together to do what's best for the drainage system as well as that wetland restoration on private lands. As part of that, we also actually split Section 805, which is the removal of property from or partial abandonment of drainage system. If you're going to do a wetland restoration on a drainage system, particularly at the upstream end, well, there's no reason to have that drainage system be part of what needs to be maintained. As a matter of fact, we don't even want it to be maintained if you're going to do a restoration. So a partial abandonment needs to occur. And the language was very, very unclear as to exactly how to do that. We split these two functions into 805 and now 806. It's a lot clearer. We're having a lot easier time working with drainage authorities for wetland restorations because of these changes in the law. There's a lot of dollar limits within drainage law. One of those was how much money a drainage authority can maintain in a repair fund. And there was concern that that number was highly outdated. As a matter of fact, the last time it was changed was 1980. It was $20,000, I believe, previously. If you just index that up by inflation, it's like $100,000. So that's in fact what we did, was recommend changing that to a $100,000 limit, and went through all of drainage law and looked at those numbers and thresholds, those limits and thresholds, and updated all of them. Some of those needed to be updated to correspond to changes in Uniform Municipal Contracting Law. The limits within it had been updated a year or two before, so those were also made to correspond. Requiring a drainage inspector if a drainage authority has any Chapter 103E systems under its jurisdiction, it needs a drainage inspector. Doesn't say who it has to be, doesn't say it has to be a full-time employee, just says you need somebody who performs that function. We also added an authority for Bowser to do this drainage stakeholder coordination. We didn't really have any clear authority to facilitate the drainage work group. This year, there's some more that were adopted by the legislature. We added provisions to clearly enable reestablishment of drainage system records that are lost, destroyed, or otherwise incomplete. Drainage authorities have been doing this for a long time, but it wasn't clear how they're supposed to do it. So now we have consistent definition of how to do that. Enabling official copy of drainage system records where, for example, part of a system is turned over to a watershed district but not the whole system. Well, actually both the county and the watershed district need records. This authority now enables an official copy. Clarifying authority for wetland and water quality improvements. Again, this was that impoundment section. This is repair. So just clarifying that drainage authorities can integrate wetland and water quality improvements. And here's another one that we did. We enabled a two-stage ditch cross-section where there's a repair by petition. And we corrected some language in there. One more slide. This is a two-stage ditch on the left. This is an existing drainage system, the south branch of the Buffalo River, where there are springs at the headwaters. It runs all the time. So perennial low flow. Mother Nature carved a low flow channel within that trapezoidal ditch. And there had been sedimentation over years too. But lots of good aquatic habitat in this ditch. It may look not much, but actually it's about 4 feet deep. And so it has riffles and pools, it has great habitat for, and in fact there's fisheries in this because it's a spring-fed system. Here's an example of where a two-stage ditch was put downstream of a trapezoidal ditch, just to see what that looks like. But what that authority now allows is the Drainage Authority could, instead of digging this out and having it actually return to this shape over time, you could potentially widen the ditch a little bit, create a two-stage ditch, has the same hydraulic capacity as the original ditch had, just a different cross-section. So it's something that the law didn't really provide for in the past, now it does.